Today my lecture is on the topic electric field intensity at a point on the equatorial line of electric dipole. Firstly, let us consider that AB, that is dipole, having minus q1 plus q charge. Let O is the midpoint of dipole and 2L is the length of dipole. P is our observational point which is on the equatorial line which is perpendicular to the dipole, passing through the midpoint of dipole. Now P is the point on the equatorial line. You have to find the intensity at point P. Firstly, at point P, the intensity due to positive charge will directed in this direction along PD outward due to positive charge. Similarly, the intensity due to negative charge minus Q charge that will directed along PC direction because of negative charge that will act inwards. Now let us consider that distance of P from the midpoint O is R. By taking the Pythagoras theorem, you will get that AP distance or BP distance, that is R square plus L square whole under root. Okay. Now E positive is given by 1 upon 4 pi epsilon naught Q upon BP square. BP is the distance between these, and along PD, that will directed along PD, which we have already discussed. Now put the value of BP here, you will get first equation. Similarly, intensity due to negative charge is given by 1 upon 4 pi epsilon naught Q upon PA square, distance square, that will directed along PC, now which we have already discussed. Then put the value of PA here, you will get second equation. As two vectors are directed along PC and PD direction, so you have to find the resultant of these two vectors. Let us consider that is angle theta, that is also angle theta. Then that angle becomes 2 theta because that is the external angle of a triangle which is equal to the sum of two other angles. Okay. Now by applying the parallelogram law, you will get the resultant. Magnitude of resultant is R is equal to under root A square plus B square plus 2AB cos of theta between them. Then by applying this, you will get E positive square plus E negative square plus 2E positive E negative cos of 2 theta because angle between them is 2 theta. Now as E positive and E negative are equal in magnitude, as you can see from equation first and second, so you can write here E positive instead of E negative. You will get this equation. Then by adding these two, you will get this equation. By taking common 2e positive square, you will get 2e positive square into 1 plus cos of 2 theta. By using the trigonometric formula, 1 plus cos 2 theta is equal to 2 cos square theta. You will get this. By solving this under root, you will get E is equal to 2 into E positive into cos of theta. Put the value of E positive from equation first and cos theta from triangle AOP, okay, by taking base upon hypotenuse. Then that will give you result E is equal to 2 into 1 upon 4 pi epsilon naught Q upon R square plus L square into L upon under root R square plus L square. Then by using P is equal to Q into 2L, dipole moment, you can write it as this, okay, and its direction, that is along a negative x-axis, as you can see from the figure. Now you can also write it in the vector form. E vector is equal to 1 upon 4 pi epsilon naught minus of P vector instead of along negative x-axis. You can also show the direction by using this negative sign. If the dipole is of short length, then you can ignore the length of dipole, then you will get the result this R square under root 3 by 2 because you can ignore L, so you can cancel these two and get the result this. Thank you.